So let's do the question 70. So we are going to talk about this solubility product, which is another way of saying this equilibrium constant. So reaction, the AgCl solid is becoming Ag plus Cl minus. These are aqueous solutions. Aqueous, right? Then the equilibrium constant is actually given by concentration of Ag plus and Cl minus, right? And this reaction, by the way, is a solubility product, so we actually have Sp as a subscript, and this value is 1.8 times 10 to the negative 10, and what we are trying to find is calculate the molar solubility of this particular molecule, which is AgCl. So let's just do that one right here. So Ksp is 1.8 e to the negative 10, and the molecular ratio is 1 to 1 to 1, right? So 1 AgCl will produce 1 Ag plus and then Cl minus, right? So let's just put the X to be Ag plus, X to be the concentration of Ag plus right here. Then Ksp is actually equal to X squared, right? Oops. So what is X? And that X is also equal to the number of the AgCl, right? So number of mole of AgCl per liter. So all you have to do is to take a square root, solve for X. The Ksp is equal to, right? Ksp is equal to X squared. So solve for the X, which is equal to this to the power of 0.5, which is a square root, right? Ksp square root is X, so that's that. So we can actually dissolve this many mole of the mole of the AgCl in 1 liter solution. So if you can actually get the molecular weight, you can also get the solubility in gram per liter as well. I'm not going to do that, but you can. And let's just try to do the zinc halide case. So for this particular case, so let me just try to erase everything. So zinc, it's not halide, it's zinc hydroxide, OH2, that's another solid, is trying to become zinc 2 plus 2OH minus. So if I actually put the X to be, let me just try to write out these things before I forget, e to the negative 17, right? And then I am going to put these things to be zinc 2 plus. And then what is the OH concentration? OH concentration. OH concentration is actually 2x, right? So what is the KSP? KSP is x times, right? X times 2x squared. So for this particular case, you have x times 2x squared, right? So which is the 4x cube, right? So to actually solve for x right here, because that's going to be the number of mole of zinc hydroxide can actually fit into this 1 liter of water, right? So is equal to this one divided by 4, but I'm going to put the parenthesis because I'm going to have a whole thing to be power of 1/3. Do you know why I'm actually doing the 1/3? Because it's the inverse of the cube, right? So, yep, that's the number of mole of the zinc OH2 that can dissolve in 1 liter of the solution.